Every Google search you perform, every Amazon purchase you make, and every movie you stream travels through a hidden world of thousands of digital factories scattered across the globe. We call it the cloud, but the reality is much more heavy, much louder, and a lot thirstier than the name implies. Right now, we are in the middle of an unprecedented data center gold rush. These windowless buildings are the beating heart of modern civilization, powering everything from your medical records and banking transactions to national defense and the explosion of artificial intelligence. But as these digital warehouses grow into gigawatt-scale campuses, they are beginning to collide with the real world in a way we've never seen before. From guzzling billions of gallons of water to pushing regional power grids to the breaking point, the hidden cost of our digital lives is starting to come due. Today, we're going inside the fence to see who really owns the cloud, who uses it, and the massive, often invisible impact it's having on our communities, our wildlife, and our planet. Stay with us to find out why your internet connection might be the most resource-intensive thing in your home. In this video, we're breaking down the complex and rapidly expanding world of data centers. We'll explain exactly how these facilities work and why a single modern facility can now require as much electricity as 80,000 homes. We'll reveal the hidden users of these buildings, moving beyond big tech to show how the Department of Defense, global banks, and even local hospitals rely on this infrastructure. But more importantly, we're going to look at the side of the industry that rarely makes the headlines. The 24/7 noise that keeps neighbors awake, the air pollution from massive diesel backup generators, and the growing threat to wildlife like salmon in the Pacific Northwest. We'll wrap up with a detailed side-by-side comparison of the pros and cons so you can decide for yourself. Are data centers a necessary blessing for our economy or an unsustainable curse for our environment? At its most basic level, a data center is a specialized industrial-scale building designed to house thousands of computer servers and the networking equipment needed to keep them running every second of every day. You can think of them as the libraries of the 21st century, but instead of physical books, they store, process, and distribute trillions of gigabytes of digital data. To function properly, these digital factories require two things in staggering quantities: electricity and cooling. The thousands of servers packed into these buildings generate an incredible amount of heat, so much that without constant intervention, the hardware would literally melt within minutes. This necessitates massive cooling systems. Some facilities use air cooling, which relies on giant industrial fans to circulate air, while others use evaporative cooling, which uses water to pull heat away from the machines. A single large data center can consume upwards of 200 million gallons of water annually, and the collective industry in the US was estimated to use 17.4 billion gallons in 2023 alone. Beyond just servers, these buildings are packed with miles of fiber optic cables and complex power delivery systems. Because the services they provide, like hospitals and emergency response, cannot afford to go offline, they are equipped with massive, uninterruptible power supply, or UPS systems, and rows of commercial-scale diesel backup generators. These facilities are essentially fortress-like environments designed for maximum reliability, often boasting 5 nines of uptime, meaning they are functional 99% of the year. When you upload a photo to Instagram or stream a series on Netflix, it's easy to assume your data is living in a building owned and operated exclusively by Meta or Netflix. But if we peel back the layers of the cloud, we find a complex multi-billion-dollar hierarchy of ownership that most people never see. The reality is that there is a massive difference between the company that owns your data and the company that owns the physical building where that data is processed. At the top of the food chain are the hyperscalers. These are the giants you know: Amazon Web Services, AWS, Microsoft Azure, and Google Cloud. Together, these three companies control a staggering portion of the nation's computing capacity. industry estimates suggest that AWS alone accounts for 24 to 28% of the total US data center capacity, followed closely by Microsoft Azure at 20 to 23% and Google Cloud at 11 to 14%. While these companies do build and own many of their own massive high-security campuses, even they often lease space from specialized real estate giants. This is where the data center REITs, real estate investment trusts, come in. Companies like Equinix, Digital Realty, QTS Realty Trust, and Iron Mountain are the true landlords of the internet. They don't necessarily care what data is being processed. They provide the picks and shovels, the physical shells, the high-capacity power lines, and the industrial-strength cooling systems. A single data center building owned by a REIT might house server racks from hundreds of different organizations simultaneously, ranging from a local hospital to a global bank or even a secret government agency. This brings us to the hidden users of America's data centers. While cloud computing accounts for roughly 60 to 70% of total capacity, the remaining 30% is occupied by the critical infrastructure of our daily lives, the federal government and Department of Defense. These agencies use an estimated 4 to 6% of the nation's computing capacity. This isn't just for payroll. It powers everything from military AI and intelligence analysis for the CIA and NSA to complex weather forecasting by NOAA and scientific research at NASA. The government is currently in the middle of a massive transition, moving many of its non-sensitive operations from privately owned facilities into these commercial clouds to save money and increase speed. Financial institutions. Banks like JP Morgan Chase, Goldman Sachs and Citibank consume about 5 to 7% of capacity. For them, data centers are the engines of high-speed trading, fraud detection, and the processing of millions of digital transactions every second. In the world of finance, even a millisecond of latency or delay can cost millions of dollars, which is why they pay a premium to be in the same buildings as the major internet hubs. Healthcare and life sciences. Hospitals and health systems like the Mayo Clinic and Kaiser Permanente utilize 2 to 3% of the infrastructure for electronic medical records, advanced medical imaging, and even AI-driven diagnostics that can spot a disease before a human doctor can. Telecommunications. Giants like Verizon, AT&T, and T-Mobile use 6% of data center capacity to manage the very backbone of the internet and the cellular networks that keep our phones connected. To understand how this all fits together, think of the infrastructure as a pipeline. It starts with the electric utility, like Dominion Energy or Duke Energy, providing power to the data center owner, like Digital Realty or QTS. They, in turn, provide space to the cloud provider, like Microsoft Azure or AWS, who finally delivers a service to the end user, like the Department of Defense or Netflix. This interconnected web is why data centers are no longer just warehouses for computers, but a critical utility. We are currently witnessing what many experts call a data center gold rush, and the primary driver is the explosion of artificial intelligence. AI models like ChatGPT and Gemini require significantly more computing power and energy than a standard search or email. Because of this, the industry is shifting toward gigawatt-scale campuses. To put that in perspective, 1 gigawatt of electricity is enough to power a medium-sized city or up to 800,000 homes. The physical size of these facilities is also accelerating. In 2024 alone, the industry added more than 30 million square feet of space in the United States. The average power capacity of a new facility has jumped from 15 megawatts a decade ago to over 65 megawatts today. By 2031, it is projected that hyperscale operators will hold more than 2/3 of all data center capacity worldwide. Looking ahead, this massive demand is forcing developers to get creative with energy. We are seeing predictions of on-site power generation, where data centers build their own dedicated power plants to bypass constrained utility grids. There is even active investment in small modular reactors, or SMRs, essentially mini nuclear power plants, to provide the constant, carbon-free, firm power that AI requires. The future of the data center isn't just a building. It's an integrated energy and computing hub that may soon operate entirely independent of the traditional electrical grid. That wraps up part 1 of our series. Thanks so much for watching. We've seen today that data centers are no longer just warehouses for servers. They have become the critical, invisible infrastructure powering our modern civilization, from your medical records to the AI revolution. But as we've explored, this digital prosperity comes with a very real physical price tag in the form of massive energy demands and billions of gallons of water. The cloud isn't made of air. It's made of steel, electricity, and the resources of the communities that host them. In the next video, we're going even deeper into the high-stakes battles being fought over noise, land use, and the survival of local wildlife as these gigawatt campuses continue to spread. If you found this breakdown of the hidden systems of our world valuable, please hit that like button. It really helps the channel reach more people who want to understand the truth behind the tech. And most importantly, make sure to subscribe to the channel and hit the notification bell so you don't miss part 2 of this series when it drops. We want to hear from you. Are data centers a fair trade-off for the convenience of our digital lives? Let's start the conversation in the comments below. Thanks for your support, and we'll see you in the next one.